Hello, friends of Euclid. It's a special day today because today you begin triangle congruence proofs. Remember the first day you went to kindergarten and your mom probably took a picture of you by the bus going off to your first day of kindergarten? Well, it's kind of like that today, your first day of triangle congruence proofs. So we got a few little camera effects for you here. Smile. That's how significant this is. Triangle congruence proofs. All right. So how do you do the triangle congruence proofs? You look at your givens, first of all, and you normally have a figure like this picture up here. And then you got to take your givens and use them to mark up your figures so you can kind of see what you have. You're supposed to be proving that triangle HNO is congruent to triangle RNO. And they've given you some information to start with. They said HN equals NR. So I mark those equal. Then they say NO bisects HNR. Okay, so we always have to be thinking about, all right, so what does that mean? What do bisectors do? They create two equal angles. But in this given, they actually gave me an equal sign. Here they didn't. They just gave me the information that I can make an equals statement that two things are equal. So I'm going to mark those two angles that here's NO, it bisects, creates these two equal angles. But I'm going to mark them in green to remind myself that I have to actually make a statement that they're equal. Now we're trying to prove these two triangles are congruent to each other, and we only have two ways right now to be able to prove that. One is ASA and one is SAS. And I'm going to have to prove that these two triangles are congruent to each other, HNO and RNO. All right? So now I'm going to look and see how can I get ASA from this information or SAS? To get ASA, I'd have to get that angle H equals angle R. Now I don't see any information that tells me that. Okay. To get SAS, I'd have to get that angle N, or I mean side NO equals side NO. Does that? Yeah, it does. So it looks like this is how we're going to get our triangles show that they're congruent to each other. It looks like we have side, angle, side possible. So how do we start this? Well, let's start with the givens. All right? They gave us that HN equals NR. So that's given. So we just put that's given. All right. They gave us another one too. NO bisects HNR, angle HNR. And that's also given. All right. Now I have to follow that up with the fact that these angles I've marked in green here are equal because the bisector splits it into two equal angles. So I have angle HNO equals angle RNO because if an angle is bisected, it is divided into two equal angles. All right, now here's the thing. If I want to get SAS, I need three equal symbols in three equations that have equal symbols in them. And I've got one right here. That's the side. I've got a second one right here. That's for an angle. Now I've marked NO equals ON. And that's by, remember that property that says something equals itself? Reflexive property. All right, so there's my third equal symbol. And this is a side. This is the included angle. And that's another side. This, now that I have my three equality statements here, I can say that these are congruent by SAS. So triangle HNO is congruent to triangle RNO by SAS. So how do we go about doing this? Let's just kind of back up and review a little bit what we said here. First we had to figure out what was it that they want me to prove. This is your destination. The proof is kind of like a road map to get to that destination. I need to travel down a certain road to get there. and that road's got to include three equations that have equal signs in them that either give me SAS or ASA. And so I kind of had to plan it out, and that's why we marked up this proof, this figure first, see what information we had. Notice that just because they said NO bisects angle HNI, I couldn't just put that statement in here for number 2 and then assume that everybody knows that these angles are equal. I actually have to say what follows from that. Those angles are equal. All right, so this is kind of a basic triangle congruence proof. We prove these two triangles congruent to each other. There's one other thing in lesson 4-4 that's new, and pay attention because it's important. That's why we have the whistle. Corresponding parts of congruent triangles are equal. Often this definition is abbreviated as CPCT. Corresponding parts of congruent triangles are equal. Now you cannot say that, you cannot use the abbreviation until you have, you can tell me what the abbreviation means, which is corresponding parts of congruent triangles are equal. All right? What do you think of that?
2-2. Please repeat your transmission. I can't copy you.
Copy that dispatch. It is important, so we'll repeat it. Corresponding parts of congruent triangles are equal. CPCT equal. So what does that mean? Okay, here's the figure from the last one. We knew that these were equal, and that side is equal to itself. It's in both triangles, so it's, we use reflexive property to show that it's equal to itself. So what does this mean? Corresponding parts of congruent triangles are equal. After I have proven the triangles are equal, but only after, then I can say, well, by corresponding parts of congruent triangles are equal, HO equals RO. Angle H equals angle R. Angle HON equals angle RON. All that by corresponding parts of congruent triangles are equal. I didn't need it for that first proof because they only wanted me to prove that the triangles were congruent, and I was able to do that with SAS. All right, but sometimes you're going to have to first prove the triangles are congruent and then prove some other parts are equal, and that's when you use corresponding parts of congruent triangles are equal, and I'll demonstrate that in the next proof. But just so you know, remember, triangles have 6 main parts, 3 angles and 3 sides. Once we've proved that either by ASA or SAS that the corresponding parts, or that the triangles are congruent, then we can go ahead and make these statements that are marked in green after we've shown that the triangles are congruent. And that's by corresponding parts of congruent triangles are equal. Every year some people try to use this to say that 2 triangles are congruent. You can't do that. This is after you've shown that they're congruent. Then you can use CPCT equal. Let me show you an example of that right here. All right, given C is the midpoint of AE. Angle A equals angle E, and angle ACB equals angle ECB. Well, let's mark this figure up. Always start with that. Okay, so angle A equals angle E. I'm going to mark that. See, we already have that equality statement there. So we don't have to worry about that. We're just going to have to state it as a given. Angle ACB equals angle ECD. Okay, so that means this angle and this angle are equal. All right, so we've got 2 of our 3 equality statements already, and they're both for angles. So do you think this is going to be SAS or ASA? Yeah, ASA. All right. Now, they told me in the other given that C is the midpoint of AE. Well, what do you know about midpoints? They split a segment into 2 equal segments. So I also know that I have the raw materials here to be able to say that AC equals EC. All right? So how does it work? It works like this. C is the midpoint of AE. I started with that given, and that's given. Before we go any further, though, I have to remind you of what it is that they want us to prove. AB equals DE. All right? So that's what they want us to prove. Now to get the triangles congruent, I've got this part. It looks like I can go for ASA, there, angle side angle. But I don't have enough information to be able to say AB and ED are equal to start out with. So as we were going on this journey, we see C is the midpoint of AE, and that means AC equals EC, because the midpoint of a line segment divides it into two equal segments. All right, now I got my other givens. Angle A equals angle E, and angle ACB equals angle ECD. So anytime I have two statements that are both given, I can put them in one statement. Or if they're two things equal to each other for the same reason, if you have a pair of those, you can do it all in one step. Okay, so this is given. Do I have three equality statements? I do. And it's two angles and their included sides. So it's the triangles are congruent by ASA. Now they didn't ask us to show that the triangles are congruent, but we needed to show that the triangles were congruent in order to be able to prove AB equals ED. Because now our new piece for 4-4, our new definition, corresponding parts of congruent triangles are equal, allows us to make our proof statement. Have you noticed in these two proofs we've done that the proof statement is always the very last statement we make? And that's how it works. Corresponding parts of congruent triangles are equal. CPCT equal. All right, this is an introduction to triangle congruence proofs. Have a geometric day.